Hi, my name is Margaret,
I'm Anna,
and we are going to
UCSF General Hospital to visit Dr. Elizabeth Murphy, who's a chemist.
Yeah.
After a long journey, we finally made it to the beautiful San Francisco General Hospital.
We're so excited to meet Dr. Elizabeth Murphy.
No.
Hello.
Hi.
Welcome to San Francisco General. Well, sometimes we use chemistry to figure out what compounds, what molecules are in something. So, for example, today we saw a patient who has something that we call Cushing's syndrome, which means you have too much of certain steroid hormones, glucocorticoids, and you gain weight and your face gets red. But we measure in her blood for those, it's low. The level's the opposite of what we would think. So what we think is happening is she is getting some form of that in these patches she brought in, which are from pain that she was using for months while she was in Vietnam. So we had her bring them in, and as you can see, there's ingredients on the back in Chinese, which I'm trying to get translated. But what we're ultimately going to do is chop these up, and then using some of the machinery I'm going to show you, try and figure out if there's any of these compounds in here that are causing her to get the obesity and look like she has Cushing's disease. And a lot of supplements, dietary supplements in the US and from other countries have things added to them. They're not regulated like drugs, so they can be very unsafe, and there's lots of examples where they have unsafe things added that can make people quite sick. And so we use the chemistry machines I'm going to show you to figure out what the compounds are that are causing the problem. It's the same thing we do also for urine. Say someone comes in, they have had a toxic ingestion, perhaps some substance they shouldn't have, like methamphetamines or heroin or something like that. It's the same kind of machinery we use to see what toxins they've ingested. So the HPLC, the first part of it is called high pressure liquid chromatography. So basically you have a sample, a liquid sample, there's many samples around, but, and you run it through a column with high pressure and liquid, and based on its chemical characteristics, including size, charge, molecular structure, it will come out of the column at different rates. So that way you can separate different compounds as they come out. Once they come out, they then go into the mass spec. So the mass spec figures out what the mass, kind of not exactly the weight, but the mass, the chemical mass of each compound is. And it does that by kind of bombarding it with electrons, and then you get an ion, and you have a mass to charge ratio, and from that mass to charge ratio you can then work your way backwards from where the chemical came out and the mass to charge ratio, what it is, and identify it. These are some of the things, this is the kind of machine, for example, we would use to look at a urine toxicology screen. So to check if someone had heroin or Valium or methamphetamines in their urine. This is the kind of machine. But also, I'm hoping it's the kind of machine we can use to figure out what is in these patches the patient has. So, and this is a liquid chromatography mass, tandem mass spec, which again can look at many different molecules all at once. So here, for example, you can see they're looking at C10H15N, and this is the isotope pattern for that molecule. And so this is helium gas. So this is used for the pressure for the HPLC, and you can see the different liquids that are used to wash the sample through. I mean, I don't know if you've ever seen one of these before, but this is called a LaserJet Pro printer.
Mm-hmm.